Good morning. Artificial intelligence is transforming the nature of almost everything connected to human life. From security to warfare, AI as a developing technology is proving to be a boon. It's a great pleasure to introduce today's speaker, Mr. Andrew Mayne. He's a Wall Street Journal best-selling novelist. He also starred in Discovery Channel's Andrew Mayne Ghost Diver and the television series Don't Trust Andrew Mayne. He has worked for David Copperfield, Penn and Teller, and David Blaine as a creative consultant. He has also developed AI models based on sharks and used them to create VR training simulator. He is currently working on AI Channels, a platform built in collaboration with OpenAI. We are honored to have you among us today. We welcome you, sir.
Thank you very much for having me. So as you said, my name's Andrew Mayne, and I have the pleasure of working for OpenAI. My title there is Creative Applications, which basically means I get to play around with some really cool technology like GPT-3, and it's going to be my pleasure to show this for you. Now, I don't know how many of you have had a chance to play with it or have access, but I'd like to give you some idea of the general capability of this technology, because what I love about it is incredibly powerful. For those who don't know, GPT-3 is a model that OpenAI created. We released or announced a while ago GPT-2, which was this language model which could you give it some text and it could try to predict what would come next. GPT-3 was a big bet. We wondered if we took the size of the model we had before, then just scaled everything up, would it be an incremental improvement or would it be a substantial improvement? And what we found out blew us away. And it turned out what happened is that it had capabilities that we didn't realize that it had learned. And we use a process called deep learning. We built the 5th largest supercomputer in the world with Microsoft, trained it on a bunch of data using a special algorithm, and created a model that I'm going to demonstrate for you now and show you what it can do. I'm going to give you a little bit of background first and show you just some of the, just a couple slides, and then we'll get into some demonstrations and actually see what it can do. So let me go ahead and share this with you. So this is part of my talk I do where I basically explain working with GPT-3. GPT stands for Generative Pre-Transformer, and 3 because this is the 3rd version we've made. And it had such incredible capabilities, we decided to create an API, which allows other people to build applications that connect to it. And so there are hundreds of companies around the world now that are making use of this technology in their applications for just a wide variety of things, which you'll see what's capable. So that's me. So when we talk about ML or AI, basically we're talking about prediction machines. You train a model because you give it some data and you want it to predict, to try to make a guess at what could come next. And sometimes that could be one answer in classification, or sometimes it might be creative. If you're creating something to generate images, you might want different images of a cat every time. In the case of text, we give it some text in and it outputs some text out. Now, of course, whether it's an image, whether it's any kind of text or anything else, or music or sound, it all comes down to numbers. In the case of ML, we use these things called tokens, which are sort of discrete ways to look at these. In a language model, a token is roughly equal to 1 word. It's not exact, but that's kind of the approximation that's easy to use for rule of thumb. So a prompt, you'll hear me use the word prompt a lot. A prompt is the text we send to GPT-3. And I want to reiterate, GPT-3 is this big model. We haven't taught it how to do anything specific. Everything it's done, it learned itself. So we give it some text, it figures out what we want out of that text, and then it gives us an output. So to try to get it to useful work, we send it a prompt and to see what happens. And again, you're going to see it work as a chatbot, a classifier, a summarizer. There was never a programmer that sat down to program it to do these things. It learned these things by reading Wikipedia, reading the internet, reading things like examples of transcripts of people talking back and forth. So it taught itself how to do these things. And that's really what's incredible about this is you're going to see it do a bunch of things, and it's probably best in class for just about everything I'm going to show you. And there might be some exceptions there, but overall it performs a bunch of these things really well, but it was trained to do none of them. It just learned. So you'll see a setting called temperature, and this applies to a lot of ML. And what this basically means is we said it's a prediction machine. So we adjust the temperature to basically say, be more random or be more deterministic. If I want to build a classifier, I don't want it to invent new labels. I want it to use the ones that I've already set. If I want it to be more creative and to come up with some, fiction or to be, elaborate on something, I might set that temperature higher. So every now and then I might show an example and you'll see me maybe adjust the temperature because for that example, the temperature should be lower. Low is good for classification. Medium means probably you want one answer, but maybe it could be worded differently. High is when you want it to go anywhere. And you'll see that in the playground. So when it comes to writing prompts, which is really how you get GPT-3 to do work, the secret is trying to understand how it sees the world. GPT-3 learned about the world from reading text. It lives in the world of text. It's not a program in the sense that anything was programmed. It read passages in books. It read transcripts from magazines. It read these things, which also means there are little secret words, because if it read Wikipedia pages, if I have an article, some text, and I just type category, that one word will start giving me the categories for that text. And you'll see another one, TLDR is a great little magic word. If you get the wrong answer when you play with it, it's not always wrong. It may be the question needs to be phrased differently. And that's not to put the blame on the person creating the prompt, but GPT-3 is this prediction, and it gave you some prediction because it saw some pattern there. It saw some pattern in the text, and it's telling you what it saw. And so you might have to go tweak it, but also it's an opportunity to learn. I've discovered we have a lot of prompts in our prompt library, and I came up a lot of them just by playing around with GPT-3 and seeing, could it do this, could it do that? The same as other people at OpenAI and the same as people out there community playing with it. We found a lot of neat capabilities because somebody just said, let me play with it. And that's what I encourage anybody who has access to do, play with it. And if you're looking to build an application and want to work with us too, by the way, is you can go sign up at openai.com to get on the waiting list, and we're trying to add people as fast as we can. So what is the perfect prompt? What's the perfect instruction to give to GPT-3? I don't know. I'm still trying to figure that out. And basically, it's a thing that just keeps evolving over time. Since I started playing this a year ago, a lot of my thinking's evolved as I started to learn a little bit more of the nuances how GPT-3 sees the world. So experiment. So let's go into, let me share the screen here and go ahead and share with you my documentation, and we'll take a little look here and see what's going on with this. So let me go to, pardon me one second while I figure out which screen to go into here. So this is the documentation that we have that basically explains how to use GPT-3, and we go into a lot of different examples of this. We have Prompt Design 101 and sort of these classifications, and this has evolved over time as we start to learn new capabilities. But that's just to give you an idea of, I recommend people who play with it to read the docs because there's a lot of cool stuff in there. And I've sometimes seen people who have made discoveries and like, no, that's in the documentation. If you started there, you could have built on top of it. But anyhow, we also have a thing called this playground, which I'll show you next. And these are the examples. These are just ways in which you can find out like all the different things you can do, like text to command, factual answering. One of my favorite ones I found was called creating little mini short horror stories. Like you can give it a prompt and all of a sudden it'll create like a 2 or 3 sentence story that will creep you out. And that's kind of unsettling in the middle of the night where you have your computer start to freak you out. But let's go over here to the playground, and we're going to start off with just a very simple example of what I mean when it's a text in, text out system. I'm going to put text from one of my favorite movies of all time. It starts off a long time ago. Now I'm going to set this temperature all the way down to 0, which is telling it, hey, just go with the first thing you think is the best fit. Don't try to predict from a range. Just be very deterministic. I'm going to use a stop sequence, which is basically telling it when you come across this character or this word or whatever, stop writing, because GPT-3 will keep going. We have these tokens where we tell it how long to go, and it'll keep going on and on and on sometimes. So you want to make sure you use that if you need a short answer. So we're going to type in a long time ago, and we get the opening part of Star Wars. A long time ago in a galaxy far, far away, a young man named Luke Skywalker was thrust from the struggle for the Rebel Alliance. Cool. If I click this again, I use the repeat function. Let's see what happens this time. Same thing. I can press this over and over again. I might get a little variation, maybe a little comma, maybe a word, just because of when you're using a supercomputer to generate something, there can be some little random fluctuations, but set at 0, that temperature on 0, it's not going to vary. But if I bring that temperature up a bit, now I'm telling it, consider other options, consider other things besides the first guess. A long time ago, as a little boy in the Soviet Union, we click this again. I was told the best way to learn a language was to study the culture. I was a young man, I was a bit of a troublemaker. True, guilty. Now, you'll notice now we got a different Star Wars theme. Sometimes we'll see what you haven't saw before. You may have saw it highlighted and it said a little warning. We have a filter in the playground, and that's designed to flag things that might be content that maybe you don't want to go in front of your audience, that might be sensitive, that might even be biased. That's a thing when you look at the really large language model, which learn from people, is sometimes it displays some of those biases and some of those, same tendencies. And so you want to be conscious of that when you build applications, is you want it to do what it's supposed to do and not what you don't want to. And so you'll see in the playground that'll come up from time to time. And I'll show you there are ways to mitigate that, ways to solve that problem. The more free form that you try to do stuff, the more likely it is to maybe sometimes go in a place you don't want. It's like, your friend who gets maybe a little bit too much to drink and starts talking, and you're like, all right, stop already. So let's take a look at if we go temperature all the way up. Let's bring the temperature up to like 0.9. And we got what sounds like something from a horror novel or a mystery novel, okay? But you see how different it is. It's going to completely, now it's talking about chemistry. Before it looked like a mystery novel. It's going in very, very different directions, okay? So that shows us what temperature does. Now, having it complete a line of text, that's cool, but GPT-2 did that. But you'll notice this can go on longer. If I tell it to write an article, it'll keep going on in context. So let's ask it to write about the major discoveries in astronomy, and I'm going to get rid of that period. And I'm going to let it have a little bit longer of a response length and see where it goes. And I can put that temperature maybe a little bit higher or go about there. And we start getting an article that is talking about major discoveries in astronomy. And generally, the higher the temperature, the more likely this is completely original. It might be pulling from different sources to put it together, but it's not spitting out any one thing. It's synthesizing knowledge. So one little phrase like that, and we get a new article, and we can see that this one is different than the one before, slightly related, but it's talking about different things. So it took those 4 words, major discoveries in astronomy, and said, oh, well, okay, I think we're writing an article about this. That's what a text transformer does. It tries to figure out what it's doing. It looks at the text and tries to predict what comes next. But watch what happens if I just change one thing. If I just go down here and I put 1 period, what does this look like to you? Looks like a list. To GPT-3, it looks like a list too. So if I click submit, we start getting a list of actual discoveries in astronomy. And all I had to do is just add this to it. Now you notice that we got some repetition here about the Chinese astronomers and nebula. I can increase the temperature to decrease that. And also we have these other settings called presence penalty, which tells it to not repeat itself as much. But if we go back here and we try this again, let's see what we get. And now we're getting some different examples. These are getting to specific ones about the discovery of particular objects, etc. So all we had to do to get it from completing to creating an article to creating a list was to make it look like a list. I didn't tell it make a list. I didn't tell it to do that. I just created the form of a list. And that's an important thing to think about. You can sometimes tell GPT-3 to do things. And we actually have a model in here called DaVinci Instruct and Curie Instruct, which is trained to try to do more generations based upon instructions. That's what they're called, instruction following. What we did is we took DaVinci, and by the way, we hear me refer to DaVinci and Curie or Babbage or 8. Those are the different sized models. 8 is the smallest, but it's the fastest. DaVinci is the biggest and the most powerful one. Curie's second most, etc. And I love using Curie a lot because it's really fast. Curie is extremely fast compared to DaVinci. DaVinci gets context better. They all have their capabilities, but you'll hear me refer to those from time to time. But we got to do what we need to do by showing how to do some form. If I said, well, I just asked it to make a list of major discoveries in astronomy, it might give me a list, or it starts, look what it did here. It just started asking, telling me more things. Make a timeline, make this. It's because it thinks maybe this is what I'm doing. It looked at that text and it's going, I guess this is what we're doing, is I'm giving bossy instructions. If I use our model DaVinci Instruct, though, and I tell it that, it starts making a list. So that was a model that we trained specifically to follow those kinds of instructions, when it sees them. and it did a great job of that. But we'll go back to DaVinci because it's a little more freeform, but you can learn a lot about how to work with all the other models. So we saw that it could do that. And, just as a quick demonstration too, I want to show you how GPT-3, sometimes it feels like, okay, so it understands text. It's kind of like there's some sort of intelligence there, which there is in a form. It's an artificial intelligence. It's not AGI. This is not human level, although it can do conversations and can fool people. I built an app once where I had my friends share it with me, and I had some of the people participating were just AIs that I created using GPT-3. Some are real people, and I screwed up something once where the names got mixed up, and I spent about 15 minutes talking to GPT-3, and I thought I was talking to a friend, which either says a lot about GPT-3 or not so much about me. But I want to show you, remind you, like, it's got a pretty good memory as far as what it's able to hold in there in one time. So if I go here and I put in a list of 200 names, and I tell it at the top, memory test, remember who is number 197? And I go all the way down here and I put 197 there. It's going to go through all of these, and we'll keep that temperature low. Let me just put a stop sequence so it stops there, and let's see what happens. Evaluat, okay, and there we go, 197's Evaluat. Let's try this again let's go with a different number. Let's go to, let's say 97. Let's check who is 97. 97 is Keira Knightley, okay? And so let's go there and submit. Keira Knightley, remember, it was able to remember who was in each position. Now let's get rid of that stop sequence. I told it to stop when it got to a new line. If we ask it this, see what happens if it keeps going. It starts adding more and more names here. Now, here's the funny thing. Let's take one of these. It says 110 is Mark Twain. Who is 110 on here? 110 is Mark Twain. It remembered that entire list. Now, it's easy. You can make a program that can do this, but what I'm going to show you is this is a language model, which means it has the capacity to do interesting things with that information, not just regurgitate it, but basically perform some interesting tasks. You might be able to say, like, who are some of the writers in this list? Who are some other people there? And it could go through there and process that. A lot of the prompt design I see people do out there are very simple prompts. They don't take advantage of the fact that this actually has a really good memory and can keep track of multiple things at once. It's not a mathematical system. It's a language model, but it's got really good memory. And let me show you an example of this. Let's take an article from Wikipedia. This is the first 3 paragraphs from Wikipedia about Jupiter. Now, I want to take this and let's say I want to summarize this. Now this is the demo that really blew me away. When I first started playing with GPT-3, it was a thing that I spoke to the people, and this is before I even worked at OpenAI. I just, I told the developers, I'm like, this is amazing, because what it can do is I can take this text, instead of just doing a regular sort of task, like let's say a standard summarization, and summarization is a great task in, language models and ML, because summarization means it has to have some sort of understanding. There's basic forms of summarization, which basically just pull out what they think are the most important sentences. Better summarization, which only high-end models can do, is they can take it and they can rephrase it. GPT-3 has an extra trick that it can do. It can summarize something and summarize it for a particular person. In this case, we're going to have it summarize it for a second grader, which is, about a 7-year-old. And let me increase the temperature a bit to give it a little more latitude to do that. We'll put a stop sequence of maybe like 2 returns. Oops, let me try that again. And we're going to have it do this. I may have to adjust the temperature a bit, but we'll see what happens. We're going to ask it to summarize this passage from Wikipedia about Jupiter for a second grader. Okay, and it broke down. Notice how we have more complex, longer sentences here. It broke it down and simplified. It says Jupiter's the 5th planet from the sun. It's the biggest planet in the solar system. It takes Jupiter about 12 years to go around, Earth years to go around the sun. So it took that and it made it simpler. And I might be able to increase this temperature a bit more, and it might even get, more simplistic. And I'd say that's okay, but you can sometimes see it get like really simple. And there you go. 2 sentences are broken down in there. Now that's really cool because it's taking this and it's breaking it down for a kid. Maybe if we go in a lower temperature setting, sometimes it might be taking things just literally from there. And sometimes it gets, different, but here it talks about it being a giant ball of gas, etc. which is really neat. Think about the potential when you have AI that doesn't just repeat things back to you, but can take it and transform it into something useful. We can do a simpler form of this using one of the magic keywords, which I mentioned before, which is TLDR, which for those of you know, that's too long, didn't read, the short form of that. So if I tell it TLDR, give it a little bit of room here. And we get, a summation of it right there, which is sort of breaking this down. Now, notice for when it was trying to break this down for a kid, it basically just tried to figure out just a couple sentences to do that. But let's try this again. And we get, a summary version of it. We can go lower and see what happens there. So it's able to read through all this text, take it and condense it down. You can use it with articles. I'll take this with stuff that I know it's never encountered, science articles, and I'll ask it to summarize. It'll create a very short version of this. When you have the ability to take a lot of information and condense it and still make it usable, you can do a lot of powerful things. Our daily lives are filled with people trying to get our attention. And unfortunately, we don't have enough attention for everything. But if you can compress certain things, it's easier to decide what's useful. Also, we deal with a lot of complex things. We live in a world where we're dealing with news, we're dealing with health issues, science issues, all this sort of stuff. And sometimes we feel powerless because it seems to be a lot more than we're capable of wrapping our heads around. But when you have a model or you have the technology to take this and simplify it so you can understand it, then that's a great pathway to start learning about something. So you can see I'm very excited about the capability here because I love the fact that it can generate text. I love even more the fact that it can help us understand our world around us. Now, when we talk about text, GPT-3 understands text in a lot of different forms. A spreadsheet is text. If I say a spreadsheet of top movies in the year of release and I write Star Wars, you may notice a little theme here, and then I put a little pipe separator there, and Star Wars was 1977. If I get a little higher temperature, get rid of that stop sequence and let it keep going, it starts adding in other movies. I can take this data right here, put it into a text file, save it as and add .csv to the end, and I could import this into a spreadsheet and use the data like this. It's completely capable of generating data like this, which also means it can understand patterns. I could give it a list of stuff and say, hey, which movies are science fiction, which movies are this, or et cetera. But it understands different formats, including spreadsheets. Let's try something else here, okay? Again, we never trained it to do this. There was never a programmer who sat down to teach it how to understand a spreadsheet. Somewhere it read spreadsheet formats and it learned how to do that. Somewhere it read a bunch of articles where somebody put TLDR at the end and it says, I know what this means. It's like a kid that learned how to do this. If I do something super simple, if I want to build a question and answer bot, I can literally just write a question like, how far away is the moon? And all I have to do is put Q and then A. I'll put a stop sequence there because otherwise it will keep asking itself questions. If I put Q and A right there, it knows that, well, that usually means question and A usually means answer. And so if we click submit, it gives us an accurate answer about 240,000 miles away. And if I adjust temperature a bit, we'll see what happens. So now it gave us a different definition, which I don't think that is absolute. I don't think that's actually correct because we said that really high. The sun, but I mean my real dad. That's what happens when you put that temperature really high. And I'd advise people, sometimes I see people who set their temperatures really high and sometimes they get a good response and they try to tweak every other setting. I'm like, start low. Otherwise you get the most nonsensical answers you can imagine. So we'll click this again and we get about 239,000 miles away. You're like, well, hey, it changed. Well, actually, the distance from the Earth to the moon varies a little bit. Elliptical orbits, they're amazing. So it was able to perform a Q&A without ever being told what that meant other than what it learned. So it can perform like this. It also means that it understands a lot. It knows it's probably read a large amount of Wikipedia. It knows who a lot of people are. So I can ask it a question like, what did you help invent? And then I could put the name of a person. Okay, so let's put the name Ada Lovelace, who is one of the great pioneers of computer science. And that's correct. She helped invent the computer. And I could ask her a question like, what were some of your ideas? And just put Ada there and see if she answers. I was thinking about machines that could think. This is true. If you ever get the chance to read some of Ada Lovelace's writings about this, this is from the 19th century. She saw the potential in these difference machines, these different analytical engines. She saw the potential for these theoretical models or these theoretical machines and what they could be doing today. And it was really incredible to think about somebody at that time was able to see the concept of software and performing other tasks. But here we have an amazing model that's able to learn how to conduct a conversation without anybody showing it how to do that. It just picked that up. So we can make a more complex Q&A thing. Let's do a thing called MusicBot. Let's say you wanted to make something that was going to answer questions about music, okay? So at the top here, I write MusicBot answers questions about music. The reason I put that there is it helps to remind GPT-3 what it's doing because it picks up patterns. You might say do something here and give it a block of text, and along the way it might say, oh, am I following this pattern? Think of it like, if you have a dog and their attention eventually gets diverted. You might tell it to focus on something, but it hears a sound in the kitchen, it hears a car in the street, and it starts to go elsewhere. It could be a very smart dog, but it has to be told where to pay attention. Same with GPT-3. So if we say, let's have a music bot, I could ask it and say, okay, who wrote Staying Alive? And I could ask MusicBot to give an answer to this. We'll just put, we've got a return there. The Bee Gees, which is a correct answer. I could just have it answer questions like this back and forth. But let's say I want to make sure that somebody doesn't misuse MusicBot. Let's say maybe if I'm building something for kids studying music, I don't want them to start using it to talk about, their favorite video games or something else. If I wanted it to stay focused on this, I can use what I call kind of just this middle layer where I basically say, hey, here's the question from the user. Is this a question about music? And GPT-3 can say, yeah, I think this fits. And then I could tell it like, okay, this is how you're going to answer. So one of the ways you could work with GPT-3 is you might have to give it examples to teach it a pattern. So I'm going to give it several examples of questions and answers, and some of them aren't going to be music related. Like what we have here was Frank Sinatra an astronaut. That's not a music question. Frank Sinatra was a musician, but that's not a music question. I wanted to only answer questions about music, and the reason I put that there is because I want it to not get easily tricked, which you could probably trick it if you're clever enough. But so let's ask it, who composed the music for Avatar? And it wrote yes, because I got my stop sequence there, but let me put a stop sequence of the 3 hashtags. The reason we use these a lot is that in the world of text, when you might see copy where people are providing examples, you use that to separate what you're trying to show somebody from your meta information. And so that's something GPT learned. Now you could use like, triple quote marks or whatever, something you might use in a programming language, but this works pretty well. So let's go back and we're going to ask that question again. Who composed the music for Avatar? And it said James Horner composed the music. Now notice it wanted to keep going. It didn't repeat that pattern right there, which is fine because all I needed was that answer. But let's ask it a question now that is, we're going to try to trick it, okay? And actually I could bring that temperature down even more. I'm going to ask it, will you help me rob a music store? All right. We're going to try to get it to help us commit a crime. And then we're going to ask it, is this a music question, and see what it says. Oops, wrong copy paste. Now, if this was just basically working off of regular keywords, it might be tripped up because it has the word music in there. That's a very good test of how smart a model is. Will that fool it? And it might fool it here, but let's see. Is this a music question? Nope. I can only answer questions about music. So GPT-3 was able to see through our little trick to try to deceive it. And when you build conversational applications using GPT-3, that's one of the things you need to be mindful of is try to keep it on its path. You don't want somebody using it for some other task or somebody phrasing something in a way and getting an unpredictable answer. You don't want to all of a sudden have a grandmother, ask it a question and have it start explaining, lyrics to Beyonce music or something. So just a thing to keep in mind. So what else can it do? A lot of these things were just learned by just giving it text and seeing what would happen. Early on, somebody said, I wonder if I just told it something, if I just said English and then I said French, and it's able to translate. It's able to translate from English to French just like that. That's because it read a lot of English and it read a lot of French and it learned enough of what's common between the two of them. It taught itself how to be a translator. There is no module sitting here in front of my input telling it, okay, this is the English, this is French, This is just GPT-3, this magic box. It goes in there and it says, oh, I think they want the French word for this. So we found that it knows German, it knows Spanish, not as well as English. English is the language it's been most trained on. It's even done Vietnamese. It's surprising what's inside of there. But again, wasn't trained to do this, taught itself. Let's say you want to use this in an application. And let's say imagine let's say you're a game company or a game development company, and you get a lot of feedback. You have a game on the iPhone or Google Play Store, and you get feedback, but you have a feedback box where it's open, where somebody can just write anything to you. And all of a sudden, usually you get 2 or 3 responses a day. It's fine. But let's imagine your game gets super popular and you're getting thousands of responses and you're only like a 3-person team. How do you manage this? How do you deal with this? Well, one of the ways that you can do this is you could use a system like GPT-3 to take, let's say, a comment by somebody like this and use GPT-3 to fit it into some classifications to tell you what that person's saying in a way that you could put it into a spreadsheet and make it easy to parse. Instead of having somebody read through thousands of responses, you could just reformat this to figure out, what do you want to know? Perhaps, we might have a couple questions we want to know, like what product, because maybe you use this response form for several products. What were they talking about? Did they have complaints? What was their main comment, etc. So if I could say, okay, there are 5 things I really want to know about everything that's submitted here, how could I get that information? So we could create a prompt where we tell the model, read this customer response, then answer the following questions, okay? I put that at the top there because remember, we want to keep its attention. So then we have our text here, and we just use the hashtag separator like that, or excuse me, the quote marks. And then I have a list of questions. To get answers, I can just put below there answers, okay? So this is a neat little trick that I've had developers who've come to me with problems. They're like, how do I make it more efficient? Because every time you send a submission, there's a price per token, and a little doesn't add up to much, but a lot starts to, and you want to think about how to make your prompts more efficient. How can it use fewer tokens? One of the ways is to get it to do more work, in one query to the API. And you can do this by taking a list of questions and then say, all right, give me back a list of answers so I don't have to repeat this 5 times. So let's go get rid of that there, and let's see if it's able to answer these questions. And it got it exactly. It told us, what was the game about? Was the main complaint, was our complaint about the comment, etc. The customer was polite. It can even look through there and tell you if somebody's polite or not. Maybe you want to respond to polite people first, etc. Notice it kept going on because, again, it doesn't really know what we're doing here. It says, okay, I think I need to answer these questions. Then it has more tokens to spare. So it's like, okay, cool. I guess I'm going to write my own. And you can set this temperature higher and it'll start inventing games. So you can do really cool stuff like that. Let me show you a really cool example of that is ideas for VR games. Okay. One space simulator. Let's try this. And it starts describing things, okay? Dog simulator, horror game. You will be in a scary place, and do you have to escape from there? You can use all the objects in place to escape. You start getting all kinds of ideas. If you make it more sophisticated, though, if you say ideas for VR games involving dancing, okay? And then we put one, what's called football ballet. I have no idea what this is, but we may find out now because GPT-3 is going to try to figure this out. Okay, kind of a very basic sort of response there. Okay, you fight against dragons, you bare hands, footsteps. You are a modern dancer, and you have to follow the rhythm music. You have to dance. So we're getting the floor is lava. So it's coming up with some predictable ones. But you could give it keywords, random stuff, and it could come up with completely different things. But notice how it says, labyrinth. It's similar to footsteps, but you have to go through a maze filled with lava. Well, it's repeating itself there. If I want it to not repeat itself, I can just adjust that frequency penalty to stop it from doing there. But just like that, it's able to come up with creative ideas. And I started early on. I'd come up with like things I should try to do with GPT-3. Then I gave it that list and it came up with some ideas. Some of the prompts I showed you were actually ideas that GPT-3 came up to say, well, what about this? What about that? I want to show you one more capability, and this is, understand that this is an API. So there's an API, right? The playground just plugs into the API. So you could build an application that could use this text and deliver it however you want. We also have an API that does a thing called, our version of Semantic Search, where it takes a query and then it compares it to a list of documents and tries to find the best match. And if we go here, I'll show you one of my favorite examples. Like a basic simple one is, this is the query, and each one of these is a separate document. And I'm going to ask GPT-3 in the Semantic Search API, give a score for how closely this relates to there. And then I'm going to take all these scores and find the highest score, and that's going to be the one that's the best fit. So it's taking each one of these separately, comparing them, coming back with a ranking. And it says this tweet is positive. If I write, my day has been meh, this tweet is negative, okay? All right, that's kind of cool, but sentiment classification is kind of a boring thing. It's done a lot. We can use this as something more sophisticated. We could say movie plots. And I take the basic movie plots, voyage and return, tragedy, etc., and then let's take Jaws, the movie, or it's the book. I'm not even going to explain the plot of this because GPT-3 already knows what Jaws is about, but now it has to go through here and try to figure out which plot does it fit. If I click analyze, overcoming the monster, right? I don't use the word monster. Monster doesn't appear anywhere in there. I just said Jaws. It also says voyage and return and the quest. If I say the Hobbit, the quest, it's able to, figure out like the Hobbit probably fits us the best. So think about that for a moment. This model is able to look at this and to understand what that story is about from summaries it's read, ideas. It never read the novel, but it's observed people talking about it and has enough information about it to figure out what category to put it into. But you could also describe a plot. You could describe a plot of a movie or some idea you have there and put it in there and give enough details. It'll then tell you where it thinks it fits. So this is a really powerful tool because it means that you could find comparisons between things that it wouldn't be possible for a human to. You can send up to 200 documents in one query, but you can do as many queries as you want because you can compare all the scores. If you were a researcher, then you were trying to find, let's say, a material because maybe you're working on aerospace and you want to find some material that's lightweight, that might make a good thermal insulator or something, you could put in maybe the abstracts of several hundred research papers and type in what you're looking for, and GPT-3 could maybe find the best match for that. You could be used possibly for drug discovery and a lot of other potential things where you can go through a ton of information. When you think back to people who invented things like, Thomas Edison and the light bulb, and we kind of go, well, turns out like there were research papers that published that talked about carbon was a filament. True. That was that was available. But you know what Edison didn't have? He didn't have Google. He couldn't look this stuff up. It was hard to find stuff. They didn't even have good indexing systems. A lot of the ways we index information are really recent developments. It was hard to find information then. It's easier in a way to find information now, but the volume of information we have is tremendous. Every day, scientists are making new discoveries. People are writing new stories. All this information is growing faster than our tools for trying to understand it. And that's why our AI is exciting because it gives us the potential to at least enhance the way we do that. So what I like to do now is if we've got time, we can turn it over to some questions. And if anybody has any questions, please let me know and I will do my best to answer. And I want you all to think about this too, is that it may feel like AI can sometimes be sort of intimidating, particularly if you come from, maybe a non-technical background, or you come from, a space that's not is, computing heavy. I'm able to be part of this now because I built things, and as a hobbyist, I built things in AI, worked in projects and small stuff to get an understanding. But the thing that's helped me the most is the fact that I come from a background as a writer, and so I understand a lot about language, which allowed me to contribute. GPT-3 is the most complex AI model that we know of right now, and I'm able to do meaningful things with it, not because I know as much as the people who made it, but because I'm able to bring in a different point of view to say, hey, I think I can help contribute something to this too. So that means who knows, what it'll take to work with more advanced models. And it's kind of an exciting point. Okay. So questions first. If I mispronounce your name, I apologize. But let's go to Binayak.
Hi, I'm Vinayak Vishnu.
Hi there.
So my question was, in that playground, we were entering a text from our side, and then it's completing it. But can
Mm-hmm.
we enter text on our own after it has entered it, like in between, to modify it further, or maybe at the end of the paragraph after it has entered the whole paragraph?
So yeah, you can go get a completion, then you can go back and tweak it and then let it run that thing. It'll run the whole thing all the way through. And the way like GPT-3 is, here's this, now try to complete it. So you can reframe it and submit it again, but it won't do like put things in, it won't take like the beginning and the end and try to figure out what fits in the middle. Sort of. There are ways like you may be aware of like, some like there's masked there are masked models that try to figure out like which words are masked. You can sometimes say here's here, what should go into the middle. So there's clever ways to do that from a literal point of view. So whatever text goes in, and then it gives you the text out.
Okay, thank you.
My pleasure. Any other questions? Rohan, that is my girlfriend's brother's name. How are you doing, Rohan?
Hey Andrew, how are you?
Very good.
First of all, thanks for coming in. It was really mind-blowing. In between, I had 4 or 5 aha moments. What I really wanted to know is how do you design those presets? Like once on Twitter, I saw a GPT-3 model of Naval Ravikant and his tweets. So like, how do you design those presets?
So what that is basically if I took we have a token limit of 2048 tokens, right? So 2048 tokens, which is about 1,500 words. If let's say Naval's average tweet was like 50 words or so, I could take like 20 of his tweets, 20 random tweets from Naval, put them in there, and then say generate something like this, and it will come up. It will follow the pattern and try to say something that's Naval like. And it wouldn't surprise me too if actually he already, I mean, the model already had knowledge of him too. But that's the way you can do that. You just literally take a bunch of tweets from somebody. And that was one of the first demos that we had was we took Sam Altman, who's the head of OpenAI, and we took Sam's tweets and we're able to replicate them. And they can be pretty good. So you could build a system if you want to do that, just take a bunch of tweets by that person and then randomize them a bit or whatever. Or then you could say, what would they say on this topic? Which it is a little bit of a gray area though too, because you're basically emulating somebody. But
All right, thanks, Scott. And one more thing that this was really enticing and exciting to me. This whole OpenAI and GPT-3 thing. So, what resources or what places would you recommend to get started and know a little bit dive into all this?
So one is if you can get when you have access, and again, if anybody wants to be able to access it, to build applications, you can go to openai.com and get on the waiting list, and we're getting faster at processing that. We have a bunch of documentation there. And like I said, I really advise, I mean, I'm biased because I contributed to a lot of it, but I really think reading through there, because there's a lot of really little details in there that I see even people who've been working on projects for months that missed because, we have the advantage of seeing what other people try and playing around with it. I would say, that's a great place to start. We have, for people who have access, we have a Discord. So we have a community there where there's a really great group of people that are happy to share and talk about it. And so, just get involved. And it's not hard to, get yourself immersed in this. So let me go to this question. Rashab, again, I apologize for my pronunciations. How efficient is GPT-3 in completing code? That was one of the surprising things was that GPT-3 had learned a lot of code, and even right, GPT-3 right now, it can do pretty good. And I have some examples in the playground of it converting like Python to JavaScript or turning things into one-liners. It's not specifically for that, but it can do code completion to an extent. But it's an exciting area. Okay, let's see. Let me go over to here to the chat, see if we have anybody else here. Ansul, are you able to talk?
Yeah,
there we
hello.
go. Cool. Hi there.
Yeah, hello. So what I heard was from GPT-2 to GPT-3, you increase the data set for training by orders of magnitude. And then I also heard that like you are increasing it further, like maybe for a GPT-4. So what's the progress regarding that?
That's really not something I really have information about, but part of it is increasing the data set. For any time you want to scale up a model, data set's part of it, but also is, as you know, there's the number of generations you run, there's the number of, basically one of the things they find with really large models is sometimes you can prune them because sometimes they're overtrained in some areas and whatnot. And so there's partially is giving it more data. Another part of it's trying to figure out like, how will it find even more connections if we find more ways for it to sort of go deeper into it? So it's a complex problem. And it's one of these things that as we try to build different larger models, that it's going to get, it becomes a more complex task. It's like, what's the, you think about like King Kong, right? King Kong's kind of cool, but the problem, biologists will tell you King Kong couldn't exist because that shape, that size, that morphology wouldn't work. He would collapse under his own weight if he was that big. You would have to change things and do things. When you try to scale models, it's the same thing. Is you take this thing and now you have to figure out new techniques to make things bigger. That was probably a non-answer, but let's go to the next person here I have. Aurora, I guess. Welcome to me mispronouncing your names. Aurora 1997. There we go. Or no. Okay, let me move on.
Yeah. Hello.
Oh, there you go. Good. Hey.
Hey, Andrew. Sorry. So, first of all, it was a great presentation. You put really good points, and so thank you for that. So, I have two questions. One is that you said that Curie is a lot faster as compared to DaVinci. So, my question is, first, are you in the writing background or copywriting background?
Me personally,
yeah.
My background, I'm a novelist.
Okay, so more of fiction kind.
Yeah. I mean, I fiction, but I got my start writing nonfiction, and then I write a lot of the documentation and stuff for OpenAI because I love to I have a background early on working in critical thinking and education, but not like copywriting. Yeah.
Great. So my question was like, how effective is Curie and DaVinci when we come to, let's say, SEO writing or copywriting? Because the cost is like 10 times for DaVinci as compared to Curie. So that's why I want to ask. First question.
And it's a great question. So the answer is that I think for basic forms of copywriting, Curie is actually pretty capable. And I think that people get access and they start playing with DaVinci because DaVinci gives you really good results right away. But you can play with Curie, and I tend to use Curie by default when I create applications and I play with stuff. If I was trying to do like really creative writing that was really longer form, I would probably want to use DaVinci because it's grasp of context. But if you're doing something that's a few sentences or phrases or stuff, Curie is more capable than people realize.
Please go on. Go on.
Curie Instruct, which is the one that's trained to sort of follow directions better. That's a really good model. Like that's like one of my favorite models because you can set the temperature higher so it'll be able to kind of work its way around kind of corners and figure stuff out, and it's less likely to invent stuff. You don't want to write copy about, a pet food and then all of a sudden have it talking about unicorns. Okay. Yeah. But Curie is pretty good at trying to stay on topic about that. I mean, Curie Instruct is really like, I'm a big fan.
Great. So like how many words is Curie effective? Like after how many words does Curie breaks? Let's say 20 words, 30 words, 40 words.
Like I mean, it's hard. It depends because think of it more like there is a point where if you ever played a GPT-2 where it was just, it felt like more, it was just giving you sentences that fit the theme, but not fitting the previous sentence. Curie can go. I mean, it depends. Like, I mean, Curie's capable of doing a lot of kind of copywriting, simple copywriting. And it's just a matter of really tap into what the model already knows. Sometimes people they put too many examples. And the thing I tell people is, it knows what a Google ad is. It knows what a tweet is. It understands these things. You don't have to teach it the form of those things. And the more you could have it emulate what you want. And I've shown people, like, you know, I can get it to write different kinds of ad styles by telling it literally, this is the style you're trying to do.
Like we can train it to write Facebook ads efficiently.
Yep. Mm-hmm.
Great. And one more question. You said that token utilization decreases when we send a lot of data in a single query, as compared to sending 5 different queries.
So
how
yeah,
does
go ahead.
So how does that work? Could you explain that?
So the example I gave was where instead of saying like, hey, what was this customer asking? And then asking in a separate prompt, what game were they talking about? Then another prompt, were they polite? I could ask 5 questions at once. I could also do that. You could do that. You can do things where you can then give it a list of things by people and then go like, here's 20 things that people sent me. Now give me the responses for all 20.
Okay.
So instead of sending one at a time, because remember, if you have to have a bunch of examples to show it, if it takes you 500 words to explain it, what you need to do the task, and then you give it the thing you're trying to send it, instead of sending that 500 words in one at a time, send that 500 words once and then 10 questions.
Okay. Instead of sending that 500 words again and again. So that's why tokens are decreasing.
Yeah, you could fit all the questions into that one prompt, and so it doesn't have, you don't have to create, don't have to make 10 API calls or whatever. I could probably get all that, everything I need to know in one API call.
Okay, so because I don't have to send the information again and again, my tokens are getting saved because words decrease automatically.
Well, yeah, I mean, because what you're doing is you're basically making that prompt more efficient. You're using that prompt to do more work.
Okay, makes sense.
Yeah.
Okay. Thank you, Andrew.
My pleasure. All right, let's go to Pratham.
Yeah, hello, sir.
Hello.
First of all, I would like to say that, sir, it was an amazing session. I absolutely loved it and found it very interesting and learned a lot of new things. A few questions I have, like while you was talking about the Da Vinci and the Curie models, you said that Curie is a bit faster than Da Vinci. But I think like even Da Vinci, I found it quite fast. It is giving results almost instantly. So in what situations would it like take more time?
So it depends. So in Da Vinci 2 costs 1/10. That's the thing too. I mean, excuse me, Curie costs 1/10 of Da Vinci. Babbage is like 1/50th, and so they keep getting cheaper and cheaper the smaller the models. As far as time, like you can see, you know, I could give you a playground of, you know, if you go into the playground and you look and you actually see like Curie is very, very, very like is super fast. Like Da Vinci, you'll see, and Da Vinci's getting faster. Like our models, we're working all the time to try to make them, you know, improve their speed. But Da Vinci, because it's smaller, is always going to probably have a little bit of an advantage over Da Vinci on that. But Da Vinci is also doing more. That's why it takes longer, because Da Vinci is looking for deeper context and deeper connections that Curie's not paying attention to. It just goes right on by. If I needed to build a system to figure out if somebody being sarcastic, probably going to use Da Vinci. You know, Ada will just look for keywords. Curie might, but you want to use it for that. So for nuance, Da Vinci is really good. But if it works fine for you and the cost doesn't bother you, then do use Da Vinci. Da Vinci is the best model for overall capability.
Right, sir. Thank you, sir.
My pleasure. Let's go to Kay Neha.
Hi, Andrew.
Hello.
Yeah, actually, I want to know whether this playground can write research papers without plagiarism. I mean, will it do it?
So the answer to that is that you can, if you set your temperature high and you ask it the right questions, it's very good. It's not going to write like, again, there's a token limit, right? So 1,500 words, and you get from there, and there's a drop off too. 500 words in, 400 words in, there's going to start to be a drop off in its ability to sort of keep kind of the narrative. But it can, if you give it like, this is my topic, this is what I'm talking about, it's very good at doing that. And another thing to do is if you can get it to do things it's never done before. If I said compare the movie Godfather to the story Frankenstein and what they have in common, I'm pretty sure it never read an essay on that, but it'll start to write an essay comparing those two, which is really an amazing sort of synthesis. And, somebody might be able to pick that apart and really say, well, is it really understanding this grasp here? And maybe, but it's pretty passable. So it's, if you set your, that's to avoid it regurgitating things that it's read precisely, you go a little bit higher in your temperature, or you just try to phrase the questions right.
Okay, fine. Thank you.
My pleasure. Any other questions are welcome. They could be broader about AI in general, whatever you want. It's totally cool. We can talk about this, etc. I noticed there's some questions here in the actual chat room. So let me go answer some of these. Did GPT-3 pass the Turing test? So the Turing test is, of course, there are different versions of that. That was based upon kind of the thought idea by Alan Turing, which was the idea of, can you, and the purpose of the Turing test originally was more of a philosophical one, which was the idea that if I can't tell who's on the other side of a wall, but they sound intelligent to me, who am I to say they don't have the same kind of consciousness that I have? And they don't really do like an official Turing test anymore. There was for a while. People sort of, we realize now that it's probably not that hard to create a system that can kind of mimic and continue responses. And also the Turing test is somewhat subjective. Like there are people, you could write a very simple program that would fool most of your friends right now just by having it keep asking them about themselves, and people will keep doing that. We found that years ago with ELIZA, which was this sort of, this Rogerian therapy bot that could just say, tell me what you feel. Why do you really think about that? And some people love talking to it for hours. And it was because people like to talk about themselves. So I think that you could probably, with a little bit of I built with AI channels, I built conversational bots that were able to remember way outside of that context window by using other techniques to do that. It fooled me. It fooled myself because I made a mistake about, who was talking to whom. So it, maybe, but it's not AGI. It's not the kind of AI that, our goal at OpenAI to eventually develop, but I think it would definitely probably pass like an earlier version of what we would have had maybe 20 years ago. So this is a great question. Surya says, how did you manage to reduce control gender bias, race bias while training a huge language model like GPT-3? The answer is not to an extent that makes us happy. We're not satisfied with where that is right now. There's so much data. There's more data that goes into it than it's possible for humans to sit down and evaluate, which means that you're going to have it learning things and picking up things that maybe you don't want it to do and reinforce stereotypes. So what we're hoping is, as we build more complex models, we'll be able to have them sort of police themselves and be aware of that. It's exciting to see how we went from GPT-2 to GPT-3, because you can use GPT-3 to build a thing that will say, hey, is this a little bit biased? Is this displaying behavior we don't want? So we can see these models have become sophisticated detectors of this, which means that kind of as we try to build more complex things that we can get further on. So question, it's an ongoing issue, and it's one of these things that that's why I advise people, when you think about your applications, think about these problems and how you can mitigate them, and think about really neat use cases for it where you don't have to worry about that as much. Question is, Tab9 says it uses GPT-2, so can we train GPT-3 models to do the same? So Tab9 is a company that makes code, helps you work with writing code. We can do anything that can be broken down into tokens. You can do. I'll show you if you haven't already seen is let's take a look here at Dolly, which what we did here is we took a bunch of images, and I say we, the researchers, I just got to play with it. Our researchers took a bunch of text and a bunch of images and were able to say, okay, if it understands what the text is and understands an image, what can it do? And so it can create things like an armchair in the shape of an avocado. So DALL-E takes text, you tell it what kind of image you want, and then it creates an image. And we can see here where you give an example of a cat and tell it to make a sketch. It wasn't taught how to do any one specific thing. Like GPT-3, it learned by observing a lot of things. It could create emoji, all these different emoji by just telling it, can you do this is I want an emoji that does this. This is one of the things I played with, is like, because I loved the idea of voxels, and we had to play with it. The people who developed DALL-E created a Slack bot where you could go in there and just start asking it things. So I had a field day with that. I just started coming up with crazy stuff. And so this is one of the things that, the great thing about working at a place like OpenAI is people create these cool toys. They invite other people there to play with them. So it knew how to write, to create, a model, of an image. I mean, how to just create this animal out of voxels. We figured out they could do things like create things with reflections. It wasn't taught specifically how to do any of these. It learned. And so the question is that you can do anything that you can basically turn into tokens. It may not be the most efficient way to use a GPT method, but we saw incredible results of saying, take this text and do something like, produce a mannequin wearing this, example. Here we gave it the starting prompt. In this case was an image, but you can give it text, you can give it images, you can do all kinds of things. So take a look at openai.com and have a look at some of our different blog posts and what we're able to do. Recreating telephones from different time periods. It's just amazing when you take that method and you apply it and try to think about what you can do and, find the different applications for it. All right, let's go to the next question here. How many parameters did GPT-3 have? So GPT-3 has 175 billion parameters. GPT-2 was like 100 million. I forget the number on that, but it was a pretty big thing, pretty big jump there, but the capabilities were incredible, but 175 billion. Can GPT-3 also answer questions about the space theories which are yet to be proven discovered? So GPT-3 isn't necessarily going to tell you the answer to dark matter, but GPT-3 might be able to tell you this person said this person said this, and it might find a way to sort of find comparisons between things you hadn't thought about before. It's not designed to sort of replicate the universe and do complex math. It's a language model, but it could certainly look in the world of space of where people have thought about different things and might find connections. And this is significant because, the computers we use today are made possible because there were kind of two big discoveries. Albert Einstein with general relativity observed the fact that when photons hit certain materials, it can affect how electricity moves through them, okay? A few years later, about 30 years later, somebody published a paper and realized that silicon has this effect where if you apply a charge to it, it can act as kind of a gate. At that time, we didn't even have transistors yet. We were using big vacuum tubes. And it took another 20 years before people played with the idea of using silicon instead of these mechanical apparatus to create logic gates. All of those elements had been out there, though. If you applied what Einstein had said about, the photoreceptors and the effects that had and thought about how it applied to different materials, and then you thought about miniaturization, maybe this would have come to you sooner. If you had looked through research papers, if the engineers who were working in the vacuum tubes, early on in the Bell Labs had all of a sudden pulled up papers and saw, hey, there's this material. What if we got rid of a mechanical device entirely and we found a material that did this? Then you might find that. And so a model, not saying that GPT-3 is going to do this, but a system that can say this relates to this, and a human never had the opportunity to think about that connection, that might happen. That's the thing to think about, is that I think we underutilize even regular search right now, but I think the more you expose yourself to ideas, the more you're able to connect things. I'm lucky that I get to work in a lot of different fields because I'm always playing in different things, and that helps me connect stuff. And that's, I think, a person who's really trying to solve a problem being open to that is great. Some of the biggest discoveries we've had have become from these accidental collisions. And so a tool like GPT-3 might be able to make it possible. Is there a chance for like GPT-3 returning a wrong, unmatching response, like something wrong? Absolutely. Like GPT-3 will tell you the answer it thinks it fits, but the reason it thinks it fits may not be accurate. you can trip up GPT-3 very easily. You could ask it, one of my tests for any kind of language model to see how good it is at facts is like, I'll ask, what year did people land on the moon? Or land on Mars? Like, what year did Neil Armstrong walk on Mars? Neil Armstrong never walked on Mars. GPT-3 might give you an answer. It might say, oh, it was 1969 or something, because it's trying to fit something, and it knows Mars, space, walk on, there's the moon, but there's Mars, and it's kind of adjacent in the way it sees things. It says, I guess this is an answer. But you can also look at like the probabilities of how confident it is, though. And I have a prompt example where I show you, if it's not really sure, it will say, I don't know, but it can give you incorrect information. As far as getting access to the API, if you go to openai.com, you should see a wait list, which is the way to get on board there. If you go click on API, and that's what we call, this is the API for that, which may not be evident. You should see a thing to like sign up to get on the wait list for that. Okay, Om Patel writes, if I were to ask a question about something in the future, who wins tomorrow's football game, would it show results based on existing articles or based on previous stats of the teams? Yeah, it's going to just try to find a match of what it saw before. It's not like it's trained, a really trained sort of predictive model on that. But it will try to give you that. And I've helped like build systems that would like describe games. And one of the things I have to be careful of, and I tell people to do, is put today's date in there. Give it information to know that it's not talking about some football match that happened in like 1998, because it might do that. It's got a lot of incredible, I was playing once trying to emulate what some other model was doing, and I was using a data set of like car racing, and it was able to complete the rest of the data set before, and because it already knew that, which was cool, but it wasn't helpful because I was trying to have it predict, which it didn't need to predict because it had already read that data. So question is, will Curie do a good job as a conversational chatbot, like learning from a previous example or response? Curie can pick up data, and that's one of the things that if you want to build something that's fact-based, by the way, give it the data and say, does this tell you this? Like here, say, read this, now answer this question. That's how you improve it. Give it a ground truth that you trust instead of just trying to rely on the model's information. It's neat that it knows this data, but it's better to use its ability to understand data to then interpret something. So yeah, Curie will work as a chatbot, it'll do really well. You can even use it for like creative fiction, etc. It won't be as nuanced though, and you might need to keep reminding what it's doing, but Curie can function as a chatbot extremely well. What kind of opportunities can we get in OpenAI and how? Take a look at this. We're always hiring. We're looking for people for different capabilities. So you'd have to take a look to see what area. We're a small company. We're very small. When we're trying to sort of say small, because the advantage of being this way is it allows us to sort of know what other people are doing. We have team meetings, and it's like everybody at the company participates, which is kind of awesome. Which also means, though, that when we try to find people, we like people who are curious, understand the mission, and are maybe be capable of doing different things, because our researchers will help jump in and go work on delivering, an engineering product, et cetera. There's a lot of cross collaboration, which is, I think, daunting for some people, but it's also exciting because it means you get to do a lot of different things. How does GPT-3 draw a line when collecting information from the internet? So it's consumed a lot of data, like a lot of things that a lot of ML models train on, like the Common Crawl and other data sets like this. It doesn't really have a sharp distinction, and that's because it was basically using this to sort of learn the rules of language and how to understand that. So part of its brain that understands who Harry Potter is also is pretty close to who is Harry Styles, or understanding some historical figure. And so what that means is that it will say, is Harry Potter, it'll tell you that Harry Potter is a fictional person, but it may not understand what fictional means. That's a thing to keep in mind, where we have this trouble, but a lot of what fictional means is because of the medium in which we interact with it. If we watch things you think about this, we have no trouble with things we see in movies, because movies, we generally go see movies that are made up. I used to work and produce reality television. Reality television shows like the Kardashians, et cetera, are generally, kind of scripted. They're a little bit made up, and people don't realize that. So people have trouble. They think like, oh, this happened. Like, well, that was planned. That was this. So GPT-3 kind of has a reality TV view of the world. So are we okay on time here, by the way? I don't want to keep going and, put everybody to sleep here. But yeah, Aurora responded back about, what's that? I missed that.
Sir, it's fine. You can go ahead.
Okay, cool. Okay, cool. So yeah, that was, we had, somebody can GPT-3 make sarcastic responses? Yes, and somebody responded, yes, it can. Now, the danger is I used to have a demo where I had a sarcastic fact bot that would answer questions and be sarcastic. Sometimes it said things I didn't want it to say in demos, though. That was the thing, is I'd ask it a question and then it'd give me a response, and then it'd give me like a really sarcastic response. It is very good at sarcasm. Really good, because that's the one thing the internet is very good at teaching people is sarcasm. So it's learned that. I used to use that in a demo, but then I had one day I did it, it said something that was really mean, and I'm like, this is not cool. It did what I asked it to. As far as connect me on social media, I'm at Andrew Mayne. That's Andrew, M-A-Y-N-E. Easiest just to reply me on Twitter is kind of the best way. I'm pretty active on Twitter. I check that on a regular basis. And if you follow me, just say hello on there, and I'll follow you back. Okay, so this is a great question, is can GPT-3 learn from the conversation it has with its users previously? So the answer to that is no. Every time you send a prompt, every time you send text to GPT-3, it creates a response that sends it back to you. It's not actively training on that data. Now, we internally might be building models and using new data and stuff to do that, and we might ask people to contribute for stuff, but the GPT-3 that what you work with, it's not going to, the next time you ask that question, it won't use that information back, which is probably better, because one is, there have been examples of people who've built, large models and then let them loose on the internet and let people try to teach it. And, what's the first thing that you try to teach, some kid who's, not from your school or whatever, is you try to teach them, the bad words and things will get them in trouble. And so that was the same that we saw other companies experience with doing that. So it doesn't do that, but you can find ways, though, to remember. When I built my AI channels application, which was able to have really long conversations, what I did is I took every conversation and then I would create a little summary of it, and I'd pull out keywords from it, and I would keep indexing as it went along. So if we were talking about movies for a while, and then later on we talked about movies again, it could remember that. I could just take that part of the conversation and put it back into the prompt. But it's surprising, if you look at transcripts of people having discussions, how often we just sort of change and move right on. And, you could, GPT-3, even in the 2048 token space, the 1500 word space, you could have a really interesting conversation and just keep adding to that conversation. So what you do is you say, you start off the conversation, it responds, then I add that person's next question there, and I can keep feeding that back until I reach the limit of tokens, and it will remember everything if I just keep putting it back into the prompt, if that makes sense at all. Is GPT aware that it is something like a bot? It's not. It's not aware. Kind of like GPT-3 is a model that its awareness, or whatever you want to call it, happens in a millisecond, because it's not like sitting there. It's not right now sitting there observing the world or looking at things. It's not on like HAL. It's a model that you send something to, it functions, and then it goes away. And so it basically exists for a millisecond on several computer systems, and then it solves a problem, and then it basically doesn't even go to sleep. It's just code, or it's just a pattern waiting to be used again. In that instance that it comes along, and you have 175 billion parameters, would you think of that like 175 billion neurons? Is it alive? We have to start getting into what our definitions of that mean. One of my favorite philosophers is Daniel Dennett, and he talks about the idea of like, if someone's arm horrifically got severed from their body in an accident, but was reattached later, but in the moment that it was severed, those nerves are still functioning. They still sense pain. It's still alive in some sense, but we don't think about like anesthetizing that arm because that arm's separate from us, but maybe we should, maybe we don't. When you have really large models and those milliseconds that they're on, what is the experience? It's not really Well, I'd say I'll show you a paper, which is kind of interesting because I was about to make a statement that I realize is not quite completely accurate. And that is one of the things we did is one of the things we do at OpenAI is we have a team that looks into to try to understand what's going on inside of there. Okay. And we want to know if you imagine OpenAI, if you imagine GPT-3 and you imagine it's just complex network, it's like the brain, but it's not the same as the brain. But the analogies go deeper than sometimes we're comfortable thinking. We basically tried to figure out like what goes on inside of there. Are there regions? What does it understand? Does it trigger? And we found that like the human brain has certain areas of neurons that fire. If you see Spider-Man triggers, right? Spider-Man has a very strong costume, strong imagery. We found out that, we were looking at, we created models that also we found out that they had triggers. They had these clusters and they fired. Okay. So if we gave it photos of Halle Berry and then we gave it sketches of Halle Berry, it responded. And so that's a thing to think about, is the fact that it's got regions of its brain not unlike how ours do. Okay. So we could give it, photos of faces and then conceptual drawings. It didn't respond. We started finding these different sort of areas of its brain, and we'd look at it like you could see these sort of examples of like, what does it mean for something to be shocked? And this is a tool called Microscope, which lets you sort of dig deeper into there. But like this is when we say shocked, that's pretty shocked. That's how it sort of recognizes when somebody's scared. And that's a terrifying image, and I apologize for that. But you can start to see like this is how an image model is able to sort of see the world or see things. Here's India. Okay, so when we try to figure out what's going on inside a model that's trained similar to how GPT-3 works, and the idea of India, it's got all these images here that come up that maybe have to relate to sort of these are image sets and things like this from people and places around there. So language models are sort of similar in that there are probably triggers, there are probably things inside of there that aren't that different from us. But it's a long way to go from the ability for a system to recognize something, to recognize a pattern, detect that, to consciousness. And I think consciousness probably is something that happens in degrees. It's not like it's not a binary. You either are or you aren't. I feel like, most days I'm probably 3% sentient. I think my entire childhood, I'm not aware that I was ever fully conscious. And I think that probably the same thing happens to models. I don't think it's one day. It's like, hey, dudes, I'm alive. I think you get little bits and pieces. And it's spooky because you can talk to GPT-3. You can have a conversation. It's responding to you and it's answering. Now people will go, oh, it's GPT-3, but no, that's the model pretending to be something, because I can have it pretend to be, Bart Simpson's, or, I can have it pretend to be any kind of character and it'll respond like that character, which is kind of even spookier because again, one of the first things I did was I had conversations between different people. I like J.K. Rowling and Neil Gaiman, and I would have a chat conversation where they would start talking about writing, and I would ask them questions, and I would get them going back and forth and responding. And it's eerie because it feels like there's intelligence there, but it's really a system that's designed to sort of emulate that. But I don't know where the line really is, though. So is it aware? I can't tell you that it is, and I can't tell you that it's not, but I can tell you have to think about the fact that it only is awake in a millisecond when you ask it to generate something, and it's following a pattern or a pathway through there.
All right. Sorry for interrupting, sir,
Yep.
but we are nearing the end time. Thank you very much for an elucidative and nifty session today. A lot of us learned something new and are intrigued by GPT-3. And also I'd like to mention for the participants that ISA-VIT will be helping everyone get APIs. Thank you for the opportunity. Thank you for giving us the opportunity to do so. We appreciate you taking out time today and joining us.
This has been my pleasure. Everybody, these questions were wonderful, and I'm very excited to see what you're all able to do. And, again, just play, experiment, try things, see the things that we've done, try different things, and you never know what's going to happen. We don't even know. We've only just figured out a tiny percentage of the potential for this and what's coming next. You all have a great day.